Okay, big test tomorrow. Test is on the, let's see, communication number 2 is what it's called. And it's got a lot of writing equations. We give you some info, you write the equation for the info. So here's the simplest one of them all. If I give you 2 points, 2 comma 3 and negative 5 comma 7, you should be able to tell me the equation for the line that goes through those 2 points. That's on this test. We have practiced it. It's on my top 20 list. You should have this by now. If you don't, then I'll teach you how in a moment. So give it a shot, and I'll check you in just a sec here. I'll pause while you're working on that. Okay, recording again, and if you're stuck, here's where you should have started. 7 minus the 3 is 4 over negative 5 minus the 2. Negative 5 minus 2 is negative 7, so 4 over negative 7. All right, so there's our slope. It's not done yet, but that's a slope. That's how you start. Raise your hand if you got that, same as me. Okay, good. Then you go y minus the, what's the y? I'm going to pick this point because it's easier. So I'm going to put in 3 equals m times, oh wait a minute, I know the m. What is m? 4 over negative 7 times x minus, and the x of it is 2. Now if they ask you to write it in point slope form, this is it. You should not write anything else. You should not solve it for y. You need to write it just like this. And I'm pretty sure that the directions are going to say, write it in point slope form. That is point slope form. As soon as you move this 3 over here, even though it's a true statement, it's not point slope form anymore. Now it's solved for y. And therefore it's kind of like slope intercept form, except you'd have to multiply this part out too. But anyway, a lot of people screw it up by trying to do extra that they shouldn't. Don't solve it for y. Leave it. That's an equation. All right, that's the easiest kind. Raise your hand if you know you're going to nail that one. Okay, good. Is that piece of technology being used for the right thing? All right, you don't need to do, yeah, just focus on this, please. If you were taking notes on it, it'd be fine, but you're not. All right, so let's move on to, if you had a quadratic like this, 2 comma 3, and this time there's a spot like 4 comma 7, how would you write the equation for that? Well, you need a different equation memorized. Instead of y minus y sub 1 equals m x minus x 1, you need a different one. What's this one? Y equals what? A lot of people have forgotten this equation. Got to put a star by it and memorize it. The test is tomorrow. A x minus h squared plus k. If you didn't know that already, that's a big loss. That's going to hurt you like 3 times on the test. Got to know this formula. Okay, next, how do I use it? Well, I got to plug some things in. First thing I want to do is put in the vertex. And the vertex is 2 comma 3, so I got to be careful. Negative 2 is what it's going to appear as. That's opposite of normal. That makes sense because you're on the inside. So negative 2 comma 3 goes here. But that doesn't tell me the A. In fact, this is the right answer. The only thing that's not right is that I don't know A yet. So how do I figure out A? Well, you got this other point here for a reason. This point right here can be plugged in. X is 4, Y is 7, and now I can solve for A. Everybody solve that now for A. Get the A alone. Do it in the right order and everything. Seven equals A times 4 minus 2 is 2. 2 squared is 4. Plus 3, and a weak math mind will go 4 plus 3 is 7. Can't do that. Why can't you put the 4 and the 3 together? Because you're solving and trying to get the A alone. And so when you get the A alone, you're going to subtract 3 from both sides, and then you're going to divide by 4. After all that work, what did A come up to be? 1. Subtract 3, 4 equals 4A. Notice I flip-flopped those, that's okay. And then A must be 1. So am I done? A equals 1? No, I don't want to just say A equals 1. I want to use that in the equation. Y equals A, which is 1, times x minus, and then what do I do again for my vertex? They gave me the vertex, 2 comma 3. So I put in a 2 squared plus 3. Here's the most common two mistakes. People forget to put the squared. Can you imagine that? Pretty easy to forget because you got all the numbers in the right spots. Don't forget the squared. And then the other screw up people make is, and I would always double check for those two things, the squared, and I'd look at this number and make sure it's the opposite of the point they gave you. Okay, the point they gave me was 2 comma 3. So I should be having a negative 2. Yep, I do. Okay? Any questions about that one? Okay, next kind that we need to talk about. What if they give me a whole bunch of data and they ask me to put it in the calculator to find a regression. Do you remember that kind? Okay, grab your calculators. There's 3 kinds of regression you have to know now. Linear regression, linreg. Quadratic regression, quadreg. We already got tested on that one. And now it's cubic regression, or cubereg. Want to borrow one of mine? It's no problem. Just leave me something of value like your cell phone wallet is fine. Keys work. Okay. So now, here's the data. I'm going to give it to you right off my calculator. I'm going to go to Stat, Add it, and there's the data. Can you read it? Is that big enough? I'll read them to you. 2 goes with 8. 3 goes with 27. 4 goes with 64. And 5 goes with 125. And if we're going to read the fast way, you go 2, 3, 4, 5. And then on the right side, it's 8, 27, 64, 125. Now just look at it for a second. Can you tell what kind of data that is? Is that all the first numbers being squared? Is that quadratic data? No, it's cubing. So what kind of data is it? Cubic. So that's the kind, now they'll tell you. They aren't going to make you figure it out. But I want you to see that. That's what we've got. We got cubic data, so it's probably going to be a cubic regression. So go to Stat. Go to Calculate. Cubic regression is number 6. Cubic reg. And if you just hit enter here, it will shortcut and give you the answer, but don't do it that way. What you want to do is L1, L2, Y1. Why do I want to do that? Because it'll help you calculate the answer. The cubic regression is only one little part of the problem. The equation, yeah, that's part of the problem. But the other part is to use the equation. And if we don't stick it into the Y1 line, we can't really use it. All right, so I go L1, second L1, comma, L2, comma. Y is under vars. Arrow over to Y vars. Enter, enter. There we go. L1, comma, L2, comma, Y1. I hit enter, and it says, yay, it did it for me. That means I must have had an empty spot on my Y. If it had died right there, I would have suspected that I already had an equation on my Y1 line, and I have to go in and clear it out and try it again. But I must not have had anything there. So there we go. I got the equation right there. Now, I put in an extra 100 here. I'm going to clear that out just because I want to explain why. So you'd be done right now with the equation part. But what you haven't done yet is answer a question about it. So the question might be something like this. Let's say that that data, 2, 3, 4, 5, that was a years. And let's say that those other numbers, that those were how many people they were catching breaking into their, I don't know, nuclear facility or whatever. I hate to have it be growing that much, but could talk about Iran's deal right now. A kind of interesting thing happened over the weekend. Did you hear about that? They say that they've got a breakthrough. They've got a treaty that's historic that's going to allow Iran to finally become not on the naughty list anymore when it comes to uranium. But a lot of people have concerns about it because there's well, what are we getting in return? We're agreeing to stop all economic sanctions against Iran. Not all of them, but some of them. And in turn, Iran is agreeing to not really do too much. So it's kind of a deal that gives them an extra 6 months to make another deal with us. And in the meantime, we basically agreed that they're okay as long as they don't stop. I don't know. Bottom line is, I'm a little concerned about it because they're enriching uranium. 10 years ago, they had 164 centrifuges enriching uranium, which, by the way, if you enrich enough uranium, you can make a nuclear weapon. And Iran's the one that keeps on saying they want to wipe Israel off the map. So Iran, and the whole United Nations doesn't want them to have nukes, because in the past they've done terrorism around the globe. So we really aren't too excited about terrorists having nukes. So anyway, they had 164 centrifuges. Now they have 18,000 centrifuges spinning uranium, like getting closer and closer to getting a nuke. So anyway, we just had this deal with them, which allows them to continue to enrich uranium for the next 6 months. And so I don't understand that. So you're going to hear a lot about it in the news over the next few days. There's going to be debate in Congress about, should we make a deal with them or not? Because if we don't make a deal, kind of keeps more pressure on them with these sanctions. Basically, they're getting to be like, they can't sell their oil, they can't do other things on the open market because there's all these sanctions against them. And right now they're getting like really cramped by that, and they want out of that. So they're willing to sign this deal, but so far it really doesn't do anything for the next 6 months. Then hopefully we reach another deal which makes them really have to stop. Actually, even then, in the deal it says that they won't have to stop enriching uranium. So I don't get what we're getting out of this. So on my soapbox, I'll get off now. Okay, so the years is the one side, and the other side is, let's say it's centrifuges, just since I was talking about that. And in year 2, let me look back at my data here. It had, oops, hold on, stat, edit. In year 2 it had 8, and then it was 27, and then it was 64. Okay, 8, 27, 64, and what was this last one? 125, thank you. Then, I could ask you, when would you expect them to have 500 centrifuges? Well, did I just give you an X, or did I just give you a Y? I just gave you a Y. Well, then you have to be smart about this. You've got this equation in here. How can I put in another Y number? On the Y equals side. On the Y equals screen, I could put in that 500 number right here. My problem is when I graph it, my graph isn't going to naturally go up to 500. I'll have to force it to be able to see it. So everybody put in a 500 for your Y2, and then go to your window and make sure your Y max goes to at least 500. In fact, make it more like 600 so you can see that line going across there. And then you have, graph it, equation where I can see where the two lines are crossing. Remember what the answer is? It's where they cross, right? So how do I get that? Second, calculate intersect, number 5. And then if there's only one spot where they cross on your screen, it's really easy. You just go enter, enter, enter. And it jumps right to that spot. And it's 7.93 and 500. Well, I already knew the 500 point, right? They told me that one. So what did I just figure out? In year 8, year 7.93, or about year 8, is when they're going to have 500 centrifuges. This is not real data. This is totally made up data. It's just a real situation that we're facing in the real world. All right, so if instead they had said, how many will they have in year 8? Well, I know I'm kind of close here, but that's actually 7.93. How about if they gave me an X like that? Then you go second, calculate, and what if they give you an X? What's that? Value, number 1. Because look, it says X equals on it. Just wait. It says X equals on it. So if I'm second calculating a value, that gives me an X equals spot. What am I putting there? I just told you year 8. So I'm putting an 8 right there, and I hit enter. And there it is. It apparently Y equals 512. Okay, question or comment?
Couldn't you just do like X stored or 8 stored X?
You can do it that way. I just have decided I like this way better because that way both methods come down to doing second calculate to get the answer. But that other way works, you're right. And it's an okay way. He was talking about you could store under X. Remember us doing that? You could take, but I kind of don't like that process because it's so backwards. You take 8 and store it under X, which just is kind of counterintuitive to me. So this one makes more sense to me. Second calculate, and as soon as you go to value, it brings up X equals. And the other one's second calculate intersect. Second calculate intersect if you want where those two lines intersect. And you go enter, enter, enter. Okay, so that's regressions. Next kind are a much simpler kind again. Let's shift back to this. What if it's y equals 3, x minus 4 squared plus 7? They could ask you a very simple question. What is the vertex? You see it? Should just jump right out at you. What is it? What come on? 4 comma 7 is correct. Notice that's the opposite of negative 4. That's the vertex. And then what if they ask you the axis of symmetry? Oh, wrong. Kind of right, but what's wrong about it? X equals 4. I'm pounding that in because I will mark that wrong if you put a 4 on the test. You have to say x equals 4. The piece of glass needs to be shut. I think we mentioned this before, Mr. C. Thank you. All right. Then, don't forget the x equals. If they give me an equation that's not in slope form, it's like this, not in vertex form. If it looks like this, what do you do then? What if they want the vertex and the axis of symmetry now? Very good. What is minus b over 2a? It's really important that you know which one that is. X equals minus b over 2a. That is correct. Go ahead and try that one right now. See if you can write me, or tell me the vertex by using negative b over 2a. By the way, after you do this, you'll have x. And let's say you come out with x equals 2. You're not done. All you have is the x. You got to plug it back in and figure out why. All right, negative b would be negative 6 over 2a, which would be 2 times 1, which would be 2. And that's negative 3. And I just figured out the x is negative 3, but I don't know the y yet. Plug it back in. You take this, plug it in here, and I will have negative 3 squared. Notice I'm using parentheses like a good boy. You really should, because there are times when you'll get it wrong if they're not there. Parentheses have been really important for the last few units. All right, this part right here, if we didn't have the parentheses, technically you'd do the 3 squared and make it negative, so we don't want that. Negative 3 times negative 3 makes 9. 9 minus 18 minus 7. Did you notice that these are almost always double each other, and one's always the opposite? And so that's the pattern. That's going to happen. All right, so then what's this come out to be? Negative 9 minus 7, which makes negative 16. There's my point. Negative 3 comma negative 16. And if they ask for the vertex, the answer is not negative 3. It's what? It's x equals negative 3. You have to have the x equals. If you just say negative 3, it will be wrong. All right. That was for the axis of symmetry. This is the vertex. This is the axis of symmetry. Axis of symmetries are always x equals things. They're always just this number, except you need an x equals. Yes? Okay. If we're going to make this any harder, it would just be that the equation would be a little harder. You'd still use negative b over 2a. I guess the only other thing they might have said is write the equation for it. Well, that really just means if I give you a vertex, can you write an equation? So I'm going to give you a vertex. Say the vertex is 5 comma negative 12. Write me the equation for it. And there's a really important question you should ask me. What's the a? Very good. And I could tell you that, well, another form of the equation would look like this. And that, in turn, would tell you a. Get what I'm saying? You can get the a off of that equation. Use the other equation for the vertex. I'm not saying that these two equations really go together in real life, but they'd have to somehow tell you the a. And they might do that by giving you a different form of the equation. Okay, so you go y equals a, which we know from this is 4, And then you go x minus and then squared. Don't forget the squared. Anybody forget the squared? Be honest. Thank you for being honest. It happens. And then the other part is this 5 and the negative 12. And then double check this part. Did I make it the opposite of what the vertex was? So it's a minus 5 instead of a 5. Yay, I did it right. Raise your hand if you had that one right. Okay, awesome. Now we have a bunch of time to work. Oh, wait, no, I forgot one major important section. Sorry. The stuff we just learned on Thursday and Friday of last week, and that was power functions. Okay, quick reminders. They will never say y equals because they're going to be power functions. They're going to be functions, and they need to know which one's the variable. So here's a really common screw up. And people will go, okay, yeah, it's a power function, and its power is 3. Wrong. Seems like that's right. Yeah, because how can I know which one's the constant, which one's the variable? You can see it in the problem. This right here has to be the variable. F of x, that's the variable. That's the variable. So if that's the variable, that's the constant. We usually call it k. And if that's the constant, the power is the power on this, which is a 1. You get that? It's not always just intuitive. You have to look and see, oh, they're telling me which one the variable is. That's the variable. And then it's the power on that. So this one's power is 1, and its constant is r cubed. That answer your question? Okay. All right, so here's another one like that. I shouldn't always use f of x. A lot of times I use weird things like e of m equals 5m to the third. So don't overthink this. What's the power? 3 is correct because it is the m is the variable. I can tell because of this. So m is the variable, 3 is the power. What's the 5? Constant. All right, I'm going to change this up a little bit. Say I said that. Don't start thinking of that 5 as 5 to the negative 1. That'll mess with your head too much. Just think of this as, that's like a 1/5. Do you get this would be the exact same thing if I said 1/5 m to the third? And now it's much easier to see by writing it that way. What's the constant here? 1/5. So if they put the 5 on the bottom, like this, think of that as a 1/5 out front. So what if they do this? Y of r equals 2r to the third over 5. Is it a power function? Yes. And by the way, when would it ever not be a power function? If that was an x, or there's one other thing you're not allowed to have. No, you can have negatives. 0. That can't be x and it can't be 0 to be a power function.
What about quadratics?
This is not a quadratic.
So, what's the scope as those? I know it's negative.
No, the quadratics are okay. I'm just saying this one's not a quadratic. If I change it to a quadratic, it's going to be a different problem. Let me finish this one first. All right, so if I want to take this guy and ask you what's the power, it is 3. What's the constant? 2/5. You see that? It's just as if I had said 2/5 r cubed. They mean the same exact thing. All right. Now, how about this? This is going to be different. A of x equals 4 over x squared. First thing I would do is rewrite that puppy all on one line because we really don't want those fractions like that. A of x equals, how do I rewrite that? No, the 4 is not negative. It starts with 4. X to the negative 2 is correct. Now here's a really common one. Let's say I change the problem to this. 4 over 3x squared. Kids want to move the 3 up to the top with the x. Don't do that. Do you get how this is really 4/3? Now move the x up to the top. New answer. 4/3 x to the what? Now you got it written that way, it's easy peasy. What's the power? -2, what's the constant? 4/3, and there's only one other twist to this. Because it's got a negative here, this one does not vary directly, it varies close. I know directly and indirectly go so nicely together, but they don't work. Inverse. Directly or versus inverse. This one is an inverse. Remember, that's the inverse of 2. So it's an inverse variation. All right. And that was about all you could possibly handle at the end of your first long day back at school. So here we go. I'm going to hand these out. I'm going to have you circle a few that I'm going to call optional. As in, you probably, if you haven't been getting A's on most of your tests, you should probably do all of them. But if you've been getting A's on your tests and you need some extra time in your life, I'll give you a few that would be okay to skip and it wouldn't be tragic on your grade. So there's a few optionals here. First of all, I think we've done enough of 1 and 2 that number 2 could definitely be optional. Number 4, so circle these. Number 2 is optional. Number 4 is optional. No, number 1 is not optional. Number 1 you should do. Number 2 is just like number 1. Number 2 is the optional one. Number 4 is also optional. Number 6 is also optional. They're not too tough. You would think so, but nope. I'm going to skip to number 9. D is optional. 9D is in donkey. On to the next one, number 10. Believe it or not, those are all super quick, easy questions on whether or not they are power functions and what's their power, what's their constant of variation. Those are simple, and there's stuff like that on the test, and I think it's the thing you're weakest at. So bottom line is you shouldn't skip any of number 10. You should do all of those. On number 11, there's not as much of that stuff. Oh, wait, that's a new section. We didn't talk much about number 11. It says, determine if the function is a monomial. I'm going to remind you, to be a polynomial, there's a couple things the powers can't be. The powers can't be negative. Yep. Write this down. Powers can't be neg. Powers can't be fractions. To be a monomial, can't have negative or fraction powers. Oh, they can't also be x. So look at 11b. Is that a monomial? No, because it has an x in the exponent. That's actually an exponential, it's called. Correct. All right, and therefore, since it could be any number, it might be negative, and therefore that might not be a polynomial. Okay, number 12 is a word problem, and you need to know how to do that kind, and that's probably the hardest one, so we should definitely not skip that one. Same with D and E, and unfortunately the whole rest of it, there's stuff like that you have to know. So that's enough that you're optional. This would be very smart for you to do the first couple problems with me. I'm going to start on number 9A. I don't think you'll probably need too much help until there. Number 9A. What's the vertex and axis of symmetry? Oh, wait a minute. I'm wrong. That was an easy one. Not 9A. Let's go to 10A. 10A. It says f of x is 3 over x squared. Given that k, r, and n are constants, do I have a k or an r or an n in here? No. Therefore, that doesn't even talk to me. But determine whether the function is a power function. If it is a power function, state the power and the constant. All right. My advice to you has always been, don't leave them like that. Write them like this. Now you should be able to tell me, is it a power function? Yeah. What is the power? -2. And what is the constant? 3. There we go. So rewrite them first. So like on number C, or letter C, got a lot of questions on that one. it says f of x is 5 over 2. Remember this kind? What was I saying that you should do with that 5 over 2? You should make it 5 halves. Remember, that 2 is not on the bottom and you don't move it up to the top. That's a 5 halves. And the thing that needs to be moved is this part. Do you remember what the square root of x is? It's really x to the what power? To the 1/2. And then if I move it to the top, yep, it'll be x to the negative 1/2. The reason it's to the 1/2 power is because it was a square root. The reason it's negative is because we moved it to the top. Now that that's done, it's easy. What's the power? Negative 1/2, and what's the constant? 5 halves. Very good.
So would negative 1/2 be the reciprocal and inverse of 2?
I would think of the 1/2 part not as a reciprocal. That is a square root. Anything to the 1/2 power is a square root. And then the negative of it makes it 1 over that. So it's 1 over the square root of x is what that's equal to. X to the negative 1/2. The reason we use this is because when you look at this and you say, what's the power? It's very confusing. But if I look at that and I say, what's the power? It's like, oh, that's easy. It's negative 1/2. So you want to write these like this. All right. Now, I think number 1 should be a no-brainer, and number 3 should be pretty easy for you. I'll just leave it to you then. Feel free to ask me if you need help on any of these. If you haven't noticed this yet, I have collected almost every time your review packets right before the test, because I want to make sure that you do them. So I strongly encourage you to do your review packet. If there's any one most important assignment, I'd say it's this one. Because if you notice there's something, oh my gosh, I don't get this kind, you can come in the morning. I would also check it with the answers that are posted. Okay, that's all I got for you for today.